Hello and welcome to my English 3 project on engineering. Engineering is the application of science and maths to solve problems. While scientists and inventors come up with innovations, it is engineers who apply these discoveries to the real world. Engineering is part of STEM education, which aims to engage students with science, tech, engineering, and mathematics. Yet, as a discipline, it has been practiced for thousands of years. Engineers work on everything from cell membranes to construction and prosthetics to improve engine and transport efficiencies, and developing renewable energy resources. So, what do engineers exactly do? Well, engineers are involved in design, evaluation, development, testing, modification, inspection, and maintaining of a wide range of products, structures, and systems. This involves everything from the recommending of materials and processes, overseeing manufacturing and construction processes, and conducting failure analysis and investigations, to providing consulting services and teaching engineering to students and trainees. Types of engineering. There are many different types of engineering, often divided into areas in which the engineer operates. For example, engineers working within the oil and gas industry could be petroleum engineers, while those working in farming related application could be called agricultural engineers. And now the reason why I would like to be an engineer. Well, I don't exactly have a script for this, so I'm coming off with this off the top of my head. So the reason that I want to be an engineer is because I just find all of the technology and mechanics so fascinating, and my dad does it, so I'm a little inspired by that, which my dad is the one that I'm interviewing for this. But it's all of the calculations that you have to do and how much it takes to actually build, buildings and houses, everything like that. And the computer engineers, they build technology and everything and such like that. And what I'm going to be is a civil engineer, I think. I'm pretty sure it's the civil engineers that, write out everything and build the stuff. I'm going to be a civil engineer because, well, I would like to build things for my state, my country, all that stuff. And I'm taking engineering classes this year, so this should help out. And that is why I would like to be an engineer, because I just find it so fascinating, and my dad inspires me on that. Tell me your name and your job right now.
Tony Heidel, Civil Engineering Inspector.
All right. I'm going to have a few questions for you, and then you'll be good to go. So first, how do you exactly do blueprinting? Do you know how to do that?
Design engineers do blueprinting. So for civil engineering projects, typically it would be something like a subgrade widening for a road whose average daily traffic count has exceeded the capacity of what that road can carry. So they would design a widening to increase the lanes of travel, or add shoulder width with safety profiling to keep vehicles, to eliminate departures from the roadway or crossing over the center line, such as milled rumble strips, to prevent head-on collisions. So there's safety blueprinting, and then you take your typical existing, those will be in the plans, and then the typical proposed of what they propose to do will be in the plans, and you'll have general notes and details of all the items, and there'll be specific detail sheets for each specific item, and there will be a estimate of the general items, of what the quantities are, and traffic layouts and various things like that. Those are all, and also on the back of your plans are going to be the epic sheets, which are your environmentals.
All right. Second question, what do you like about engineering?
Well, I like changing current things to make them better. And in my position, I take the plans or the blueprints, as you say. I take the plans and go out and find things that need to be changed or maybe weren't correct, and make it change to fit what the real need is. And that's they kind of call that redlining plans. So change them to fit the current condition of need.
Okay. Do you know what stress versus strain is?
I never really deal with that in our positions.
All right, that's good. 4, do you know good colleges for engineering?
Oh yeah, there's several in Texas. I mean, Texas A&M, University of Texas at Austin, Letourneau does engineering, Texas Tech. There's a lot of engineering schools in Texas. Lamar, oh yeah.
All right. Number 5. How are you exactly supposed to act on the job?
Professional.
Professional. Okay. Just straight up professional, no joking around whatsoever.
No, I mean there's okay humor in things, but it should always be in a positive manner. So there's not really room for negativity. I mean, horseplay is different than joking around, but professional. I mean, there's a time when you get out there and you go on things to loosen people up who may be stressed that I'm there as an inspector or whatever to get them to relax, to be able to go over the details and function stress-free, to lighten things up. Sure.
All right. 6. What are your greatest strengths in engineering?
I guess my experience, because when I get plans to begin with, before the project even lets, I review the plans and I look for things that are missing, like typical things, safety items, like if they're having like a certain height of what I know is going to create when they do excavation, a limit of where you have to have temporary shoring, which is placed in place to keep the earth from caving in on workers. If they don't have temporary shoring or trench boxes or trench protection in the plans, then I make sure they add that in there for safety, and that's just one example.
All right. Number 7. Do you know how hydraulic clutches work?
No, that's more in a mechanical engineering type of thing, and I haven't dealt with that.
All right. Number 8. What is a process flow diagram? Do you know what those are?
Process flow diagram, never heard of it.
You've never heard of it?
No.
Okay. How do you stay motivated during your work?
This is what I enjoy doing.
Your motivation is driven by what you enjoy doing?
Yeah, I enjoy this work, so I'm always anxious to get out there and build a better mousetrap, so to speak.
All right. And final question, what are reasons people should actually hire me? For like experience, or like what is a reason that you would hire someone?
Well, it would be several things actually. Experience is one thing, but everybody doesn't have experience. So I mean, college, and that's usually, on all the types of things when you're hiring in engineering and engineering inspection and things like that. Job qualifications are either set forth on 2 paths. 1, you have your degree, or 2, it can be accomplished by a certain amount of years of experience, which will suffice for the degree. Both is great, but that's what internships are for. Internships bring in new engineers to give them experience. And so personality, their traits, whether they're professional or not, attentive, and for a guy my age, it's going to deal with how you carry yourself. Are you slouchy? Are you unattentive? Or are you the opposite of that? Are you not slouchy? Are you very attentive? Are you focused on the interview, the questions, or whether it be formal or informal? And I would rather have somebody that's willing to learn, even if they had 20 years experience, that's willing to accept that they don't know everything and are open-minded to new things, because that is one thing about engineering, it's always changing. So, an open person that's willing to take on new things and eager to learn, that for me, that's more important than someone that has multiple years of experience that, just on a resume.
All right. Thank you very much.
You're welcome. But going back to stress versus strain, it's just typical terms like that don't always get carried over. But an example of stress versus strain. So in civil engineering, we have bridges, for example, and they are designed to withstand a certain weight load, which would be a certain amount of stress. So the traffic that would go over there, whether it's safe to carry or not, and smaller bridges would have overload weight restrictions on them, because once you exceed the design accepted amount of stress that can be carried on a bridge, then you are going into a strain or an overload, which is why when the bridges, we pour them the concrete decks, why you would not want to place hot mix on them, for example, because over, for every 1 inch of hot mix is 110 pounds per square foot. So you figure out, if you've got a bridge that's 1 mile long, of course, most of the units are about 300 feet long. So you start figuring out 300 feet by 20 feet wide, you're talking about 6,000 feet times 110 pounds per square foot. So you just added that much weight to that bridge, then plus allowing traffic like overloaded, oversized and overweight loads and things like that. Now you're going into a strain mode, which would cause there's an acceptable amount of cracking in concrete, but you'll be going into things to risk damage permanently, which would have to be repaired. So that would be going into the strain. So stress is a designed amount of acceptable tolerances. Strain is getting into overloads, which could be dangerous to the structure.
Okay.
Okay.
Thank you.
Uh-huh.